Hello, students. Welcome to video lesson number 19 or 18, I think maybe 19. We are in the last video lesson of this week being posted on early Friday morning. So please go ahead, finish and complete this video before you start that unit quiz that I should have posted as well by the time you are seeing this for the end of this week. After this week, again, keep in mind we only have 3 weeks left of our e-learning. So I'm still navigating how I'm going to go about the last week of that e-learning, right? It's supposed to be exam week. How do I do that differently as far as e-learning? Because I cannot obviously give you guys exams, right? So with that being said, the grades are actually fully up to date as of Thursday morning, I believe. So if you posted something or you turned something in Thursday, middle of the day, I have not graded it yet. But as far as like grades being visible and everyone be able to see what they've got, you can see that so far. So if you have a 0 but you turn in something, I will get to it at a later time, no worries, and I'll be able to see the date that you turned it in, so I can tell whether it's 80% or whatnot as far as the credits, right? And then the Unit 8 vocab is due Sunday, and unit quiz as well will be posted Friday today as well. So have those ready to go and finish those later this week and this weekend. All right, so number 1, what is the Doppler effect? Number 2, for our Go Blue on page 12 today, red shift blank wavelength while blue shift blank wavelength, right? So it's going to be decreases or increases or vice versa. And then 3, red is blank frequency while violet is blank frequency. Again, low, high, or vice versa. Pause the video, think about it, answer those questions, write them down. Let's go ahead and check out those answers ourselves, though. So what is the Doppler shift? It is the change in frequency / pitch of a wave, as you can see here on the picture on the right. We saw this video yesterday. Due to the motion of an object. Keep in mind, think about that car driving by while it's honking its horn. Again, the horn is going and it's and then goes down as it goes away, right? So it's going to increase in pitch and that volume as it gets closer to you, and it's going to decrease in pitch / volume as it gets away. Why? Because those sound waves, as it gets closer, are going to be closer together. They're going to be stronger. And as the car goes away, the sound waves are going to, again, spread apart. Okay, that's the reasoning for that. And just so we saw earlier, for wavelength, for number 2, for red, I think for blue shift red shift wavelength increases, right? So if we see here, the length of the waves are going to increase. They're going to get longer, right? And then for blue shift, it's going to decrease. The waves get bunched together because, again, they're going to be getting closer and closer. So the length of the wave is going to get shorter. It's decreasing for blue shift. And then for number 3, we're talking then about frequency, I guess, instead. So red is low frequency. Again, how frequent are the waves coming at you? Less frequent than we can see here with the red as compared to the blue. Blue shift is going to be more frequency. So low for red shift is low frequency. Blue shift is high frequency. Some of the basic important concepts we learned about the other day, right? All right, go ahead, guys. Add pages 12 and 13 to electromagnetic spectrum. Again, we've got, I'm thinking maybe one more. I'm going to have maybe a final notebook check coming up, and it'll be, instead of just 2 examples of pages, maybe just 3. So it'll be worth more points. So keep that in mind, like a 45-point notebook check, right? So really helpful there, or 40-point, really helpful for a grade. So make sure your notes are up to date. Make sure they're organized so you guys can get 100% on those assignments. Okay, go ahead, guys. Go back to page 11 from where we left off yesterday. Okay, and we just talked about this. Again, write this down if you haven't already. This is just an example of the Doppler effect. Again, could also be a multiple choice question on the quiz coming up. But if we look here, okay, we can see as a honking car gets near you, the sound wave frequency of the horn gets higher. And as it speeds away, the horn frequency gets lower. So if you didn't already have that, make sure to add that now as well. Okay. So I already mentioned that, so I'm not going to discuss it any longer. But let's go ahead and do our first practice question, guys. Which of the following is space mostly made of? So you look up into the sky at night. You see the stars. You see the darkness, right? What is most of that consisted of, right? What is it mostly composed of? Is it A, normal matter from the stars, so just the stars themselves? Is it B, normal matter outside the star, so is it like the asteroids, the planets, the gases that float around those stars? Is it C, dark matter, or D, dark energy, which makes up most of space? Think about it. Give you a moment. Pause the video. And the answer is going to be D, guys. Dark energy is the most, which if I'm not mistaken, I believe is 71%. The second most was dark matter at 25%. And the remainder of that was a mixture of normal matter of stars and outside of those stars. But the number one most prevalent thing in space is dark energy. Okay. No need to write this Doppler weather predictions down. We've already discussed this at another time. But again, Doppler has to do with the motion of motion. So we talk about Doppler motion of waves. Doppler radar has to do with the motion of precipitation. Remember precipitation? Well, that's a throwback from a while back, right? We're talking maybe January, right? So it's going to be the movement of rain. So in the same way Doppler SHift looks at waves, Doppler radar looks at the movement of rain droplets, right? So it tracks the wind, tracks tornado. So when we think about Doppler, we're thinking all about movement. Again, no need to write any of this down, no worries. I'm going to skip the video, guys, because again, I want to keep things concise as we get to other videos later today. All right, so what exactly is Doppler SHift? And we mentioned this earlier for page 11. Again, the topic is just the title of the page, so I don't think you need to necessarily write that down. But as a star moves back and forth, its spectral lines shift, right? So if a star is moving away, what color is it going to be? It's going to be red or yellowish in color. And as the star moves closer, it's going to be more blue or green, kind of those blue, purple, green hues in color as well. So this causes either red shift or blue shift, right? That's as we know from before, okay? And most stars are in red shift because the universe is doing what? The universe is expanding, right? So again, that's just something to just keep in mind. We've discussed a little bit before. Okay, and then to finalize red shift and blue shift, guys, go ahead, just jot these down as well. As the star moves towards the observer, the spectral lines become shorter, right, which is called blue shift. And if the star is moving away, the wavelength becomes longer, which is called red shift. Again, I think we've talked about it before, maybe written a few things down, but just wanted to take note of it and how it relates to stars. So stars change color based on what? Based on if they're going away or towards us from our perspective. And most stars appear probably yellow, orange in color, and that more reddish hue because most stars are going away. So this indicates star color to us, guys. All about whether the star is moving away or towards us. Okay, pretty simple ideas, right? I got Squirtle and Charmander here, Pokemon, right? Okay, just indicate nothing to do with space. Just a reason to put red versus blue, right? All right, let's move on. And we, again, this is a good image, not necessarily something you need to draw unless you like to, if it helps you for the quiz coming up. But the red shift, again, if somebody left, like for Messenger, if somebody left you on red, they're maybe not wanting to not wanting to talk to you as much at the moment, so they're distancing, right? And if you're feeling blue, usually, mom and dad or family or friends will go to you. They'll want to help you out. So blue shift, blue go to you, left on red goes away, right? So that's the idea. Just a good image that we've seen maybe once before. All right, last thing I want to talk about with Doppler SHift before we go into a Doppler SHift until we get to a very important topic for the electromagnetic spectrum is why we use it. What is the practicality? What is the everyday use of it? Okay, we're basically looking at the movement of stars with these studies. We're looking at how stars are moving away, and also how we've seen some stars which are called binary stars that where two stars are actually orbiting each other. Really incredible, fascinating stuff. Here's a picture of one here from an actual space telescope, guys. We have a blue star and a yellow star. And as you can see, what's really cool, again, why is that star blue and why is that star red? Well, because the blue star is currently in that orbit going towards us, and the red star or yellow star is going away from us. So whenever those stars switch places, they're going to change colors from our perspective. Really awesome stuff. We can study the heat of the stars, the size of the stars, and especially how they're going to move. Okay, let's go ahead and do our last question of the day before we get to our videos. In redshift, wavelength blank, while frequency blank. Is it A, increase, increase, B, decrease, decrease, C, increases, decreases, or D, decreases, increases? Got to know this. See if you know it at the top of your head. Okay. Correct answer. Oh, did I not give it? Uh-oh. I never gave an answer, guys. I'm going to be put on the spot. Okay. Well, let me go ahead and give it to you guys off the top of my head. Okay. So redshift, left on red, they are going away. So is that going to make the wave longer or shorter? That's going to make the wave longer, which means it's going to increase. So left on red, the wavelength is going to increase. So I know it's either A or C, okay? And then blue, they go to you. So the waves are going to get bunched up. They're going to get shorter. So the wavelength for blue shift is going to decrease. So your answer for this question is going to be C, increases, decreases. In redshift, wavelength increases, while in blue shift, in redshift, wavelength increases while frequency of those waves decreases, okay? Because they're more spread out, they're less frequent, right? Okay, our two only video questions of the day, guys, and I posted these like Thursday morning, so you've seen these for quite a while already. Hopefully you already written them down and answered them. Number one, what are the types of waves listed from high to low frequency? And two, how do rainbows form? Let's check out a quick snippets of those videos. You need to watch those on your own. All of these are all very helpful. And I want to give you guys super important. You'll need to copy this down to page 13. Copy this down, the actual chart that goes over the different waves we're going to learn about in our class. Oh no. Okay, guys. Well, you already saw the chart there, but ignore that for a moment. Let's go ahead and take a look at the YouTube videos I have that I posted. You see those already from there. But let's talk about that. The list of waves there, electromagnetic waves. Hopefully there's sound to this. Let me double check. You can never be too sure, never be too safe, right? All right. Did Mr. Campbell? I did. Okay. We have sound. We're all good. One second.
Part of something much bigger called the electromagnetic spectrum. And the wavelength changes from very short wavelengths on one end to very long wavelengths on the other. And what we see is just right in the middle. So right on this very short end is something called gamma rays. I didn't bring any today because we would all die if I had gamma rays here. But as we move our way to a little bit
So shortest, most powerful wave are the gamma rays.
Longer wavelength, and those are X-rays. So when you have to go in and they shoot X-rays in through your skin, it interacts with your bone and it takes a picture. So that's light, even though our eyes can't see it.
Okay. And again, I don't want YouTube giving me a tough time about these little clips I play, but he's going to walk you through all the different waves, and you'll need to list those out. I think, was it highest to lowest frequency? I think I had the question phrased in such a way that it was that order. And for whatever reason, my presentation keeps disappearing. Yeah, so high was the gamma rays. Then we've got X-ray. Write the rest of those from the video on your own, and we'll talk about those in a second. And then let's go ahead and check out how exactly do rainbows form as well, just to stay concise and with this time-wise. Okay. Think about light going through like a prism, or think about what happens to light when it goes through water.
Light moves slower in water than red light, so it will bend more as it enters the water. An incoming beam of white light will be spread out and separated into a spectrum of color. We call this dispersion. Now let's take this white light beam and send it through and refract back out to. Some of the light will refract into the droplet.
So here we have a water droplet, right? So if I get just regular white light and it goes to a water droplet, because typically, hence the name rainbows, right? What do they form from? Rain, right? Let's see how that process works.
Then reflect off the back and refract back out to travel down to your eye. Typically.
So there you have it, guys. To form a rainbow, we're going to say this. White light bends or gets refracted in water droplets, right? Into many colors. Again, white light bends / refracts in water droplets into many colors. So the white light gets split up, and then it makes the red, the orange, the yellow, the green, the blue, the indigo, the violet, right? Roy G. Biv, okay? So let's get into that. Let's answer all those questions with our very last thing of the day. It's this super important chart. You will need to write this down. I would have handed you guys this sheet in class, and you would have filled it out, and we would have kind of discussed it quite a bit. But I'm going to just go ahead and show it to you now, as you can see. All right. You need to go ahead and just kind of sketch this out. You don't need to color it, but do sketch this out. Very, very important. There's multiple components to this, okay? So let's start off with frequency down here, okay? Frequency. Frequency is how frequent the waves are. So as we saw in our first question, we have our types of waves down here, we have our colors up here, and we have frequency versus wavelength. Keep in mind, frequency and wavelength of waves are always inversely related, okay? They're just different. So if I've got a high frequency, that means I have a short wavelength because the waves aren't very long. They're all bunched together. If I have a low frequency where all the waves are spread out, that means the waves are longer. So you have a long wavelength, right? Okay. So from highest frequency to lowest frequency, okay? And keep in mind, the higher the frequency of the wave, the higher its energy, the stronger its energy. I've got gamma rays, as we saw in our video earlier, X-rays, okay, what we used to scan our bones and such. We have ultraviolet rays, what the sun gives off, UV rays. We have visible light rays. Again, that's with everything we see, all the colors, right? The rainbow. Infrared, okay, infrared, again, ultraviolet, then infrared. And then again, blue's always higher energy than red. Microwaves, which is what we see in space and what we use to prepare many of our foods right at home. And then lastly, the weakest are radio waves. Radio waves are the weakest. Okay, they're the lowest frequency, but they have the longest wavelength. Okay, so low energy on the far left, high energy on the far right. Super important. Make sure to write this down on page 13. This also goes into our rainbow colors. Roy G. Biv. Red, orange, yellow, green, blue, indigo, violet. Again, violet is the highest energy color you have on the rainbow, on the color spectrum. Okay, so the more blue-violet something is, it's higher in frequency, lower in wavelength, and higher in energy. The more red, orange, yellow something is, the lower energy is, the lower frequency, and the longer the wavelength. Okay, copy that down, guys. That concludes our lesson for the day. We'll talk more about wavelengths and the rainbow tomorrow, or actually on Monday when we get back to our next week of e-learning. Again, make sure to get the vocab finished for Sunday, as well as the quiz as soon as you can. It'll be 10 questions. And if you have any questions, feel free to message me on Edsby. Hope everybody's doing well. This is Mr. Campbell going ahead and signing out.